So this is a very quick conclusion on the cases. Remember that we saw 4. Ideal solution, ideal gas is Raoult's law, which is the simplest model you will encounter. Then we have ideal solution, real gas. We use equation of states, which affects both the liquid and the gas phase. Then we have real solution, ideal gas. This uses activity models, which affect mostly the liquid. And then we have real solutions, real gases, which use both equation of states and activity models. The difficult part right here is to select the adequate model to model, of course, the phi values of vapor phase, phi values of the saturated system, or the activity value of I. Make no worries, this is typically calculated by computer or any thermodynamic package, even a process simulator such as Aspen Plus or HYSYS. It's important to understand how it's calculated. In my opinion, this is a very quick overview on whether or not you can use certain type of models and why not, or why yes you can. What are the effects and changes? So for instance, if I wanted to model this part right here with an ideal solution, ideal gas model, this will be something similar to this, and of course I will underestimate this part right here and underestimate all this part here, and I am going also to lose this Asia drop. So that's why it's very important to know which type of case you are working with, and this is why deviations are caused. Later on, we're in the following section, or let's say lecture block, we're going to study deviations and why do they occur and how do they affect our calculations.